Hello everybody, welcome back to another Leetcode video. Today I'm doing the classic merge k sorted lists. We are given an array of k linked lists. Each linked list is sorted in ascending order, and we have to merge all the lists into one sorted linked list and return it. And the reason I've chosen this problem is because this can also be done using a heap, and I want to see how, because I've always used divide and conquer on this problem, and I think I solved it long 27 October. So yeah, let's begin. First of all, let's go with the divide and conquer. Well, and let me just put on some kind of timer here. 25 minutes is more than enough according to me. Yeah, so we have three lists, and how would I work? How would I do this? I know I need to partition this list, and then let's first of all make this method which merge two lists. And list 1 is list node. It can be null. And list 2 this function will merge two linked lists. And I also need to, well, essentially in divide and conquer, what we do is we keep dividing it, whatever we have, for example list in this case, until we have in this case we'll keep dividing this array until we have two lists that we can pass into this function. So for example, the first two lists will pass into this function. This function will return us a this will return us a merge list. So it's not, and then we can, then what we do is we would use the remaining list and merge it with the list returned by this function. Right. So that's the idea. How do I partition this? Well, I need an end and a starting point. And let's see. Function partition and merge lists gonna be, and I also need array list node, and also need a starting index and an ending index. Start int and end int. I can say if my start is equal to end, then return return the list present at this index. Yes. List node. And this function returns a list, so we can say okay, partition and merge lists. What's my start? Start end. List to partition and merge lists. Also mid value of some kind. Mid. Start plus end. Mid plus 1 and end. And we're simply gonna return I'm gonna simply merge these two lists. List 1, list 2. Right. And here well, if lists is null or empty or null then return lists, else partition and merge. I'm gonna pass in my list and I'm gonna pass in 0. For ending, I'll just pass the last index of this last index. Okay, that should work. Let's implement this one real quick. First of all, while list 1 is not null, simply like this, and list 2 is not null. Let's create my head is list node 0 and current point towards this head. I can check if list 1's value, or rather I should use it this way. List 1's value, if it's smaller than or equal to list 2's value, then make current is equal to list 1 move this list to the next position, else current is list to next, and of course we'll move current in every case. Okay, now for the final part we just need to check if either of the list is non-null. So if for example list 1 has become null but list 2, there are still elements in list 2, then we can simply say that current is equal to list 2. Okay, else if list 1 is not null and list 2 is null, then say list 1 current is equal to list 1, and probably at the end we just need to return the head or next. Yeah. Okay, I think we're done. Let's try to run this and see the compilation errors. Return type expected actual, then return null. Line number 39. Line number 39. Initializer is a var 36. Let's see, list 1 is of type. Okay, actually var list 1 is list 1, list 2 is list 2. Line number 40. List 1. Line number 14. Partition and merge. Actual target mismatch actual is this. Alright. Is empty or null. Let's just simply check this. If list is empty or list is equal to null or list is empty. Okay. there is no output. What's happening? Oh, let me check. Print list 1. Print list 2. What's wrong here? I'm getting my list 1 and list 2. How do I like debug this now? I don't know at what point things are going wrong. So I'm choosing my mid value. Everything's alright with my mid value, right? Yeah, 0, 1. Okay, fine. This is the base condition. Partition merge. It's wrong. List 1, list 2, list 2, list 2. head. I'm even updating the starting and ending value. Maybe this, though I know this is not the problem. Yeah, it's not the problem. So let's just see. Let's just start printing the contents of the list. Current dot value, one 1 3 4 4. That's right. Okay, so we are actually getting the right list. Wait. Oh, maybe next dot current or next dot current dot next. Cannot find, cannot assign next because current is null. Yeah, I did it because it's already on the right position because of this. Yeah, so this is not correct. This is not right. So actually we are getting the right list from this function. I don't know what has gone wrong at this step. Am I forgetting something? Like, I'm basically merging two lists. Is it because of the recursion calls that I'm losing the reference to the main list? So I'm simply returning from here. Is that right? Let's see. We have this, and imagine this is my list 1 and this is my list 2, this is my list 1, and they get merged. Okay, they are merged now. How much deeper did we go in the call stack? I don't understand this. Okay, my time's almost up, so I think I should just give up. Okay. Oh man, don't tell me because of this condition. Really? Okay. Okay. Yeah, it's still empty, so that means there are a lot of mistakes. Current.next. Oh. Current.next. Current.next and current.next. Okay. That was such a silly mistake. Yeah, let's now see how priority queue can be used. Using priority queue, min heap allows us to efficiently find and remove the smallest element. The goal is to merge sorted linked list into one sort. Since each individual list is already sorted, the smallest overall element must be at the head of one of the lists. Yes. Using a priority queue, min heap allows us to efficiently find and remove the smallest element among all current list heads. Once we pick the smallest node and add it to our result, we simply replace it in the queue with the next node from that same list. Can I get some how can priority queue be used to merge key sorted lists? Use a min heap priority queue to always pick the smallest element among decay lists. At any time the heap contains heap contains at most k elements, one from each list. So we always know the global smallest among the lists. Okay, we have initial heap. If you have 3 lists, then yeah, okay. Okay, let's try to implement that, whatever that was. PQ is equal to priority queue of type int. Now I need to access the first element from every list and store it in the queue, but I don't know how many lists there are. So how can this be done? I want to iterate over my array, and then let's see. So lists for each list, I can say lists dot value pq dot add that value, and list is equal to list dot next. Okay, and it can list can be null, so I need to check that too. So if list is not null, check. Okay, this way yeah, the lists can have different sizes, so we will not have all the elements. One, one, two. By the way, this okay, I think getting the elements, getting the numbers from the list is the actual challenge in this problem, because once we have that, then we can just iterate over the, get the numbers from priority queue and return return a new list. Or what I can do is I can say while this is not null. That I think resolves everything. Use value. Okay, now I need to make a head. Oops. Head this node 0, and I also need to make a current. While PQ is not empty, current dot next you stored the numbers only. Node is list node pq dot poll and current dot next is node current is equal to current dot next. And finally I can return this list. Return head dot next. Wall cannot be reassigned. Line numbered 17. Line number 17. Maybe I need to create my local reference of the access list. Priority queue. Come on. All properties never ordered, so it can be 17, but also on the line 17 I have this error. So let's do this. L is list. Okay. I know there's a better way to do this. I'm just not very used to Kotlin's idiomics. What is called idiomic syntax. List 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 list. Okay. Okay, that was neat. Sure. Okay, that was pretty easy. I found it much easier to implement than divide and conquer. Really, that was really easy to implement. Let's see some good Kotlin code. Oh, this is divide and conquer. Oh yeah, let's just see. Time complexity is n log k in the case of divide and conquer, which is, yeah, right, log k is the number of linked lists. We are doing yes, binary search. At each level we process all in. Space complexity is log k. The recursion stack can go as deep as log k, the height of the recursion tree. We are not using any additional data structure that scale with input size. In my solution, I was actually creating a new linked list every time we merged to linked list. Yeah, we could optimize that. We don't need to create a new one every time we merge to. But yeah, merge list one. Tell me here. Oh yeah, this solution is okay. It's doing the same thing. So I think then it's not a problem. And yeah, that condition when start is greater than end, it's not needed, as you can see here. Yeah, okay, let me see the priority queue code. Priority queue list node. Okay, we are directly showing a list nodes. Compare by, yeah, this is what I was talking about. Then we are checking all the not nulls for each node. Queue.add whereby it value. Queue is not empty. Queue.poll min node next is not null. What's that? Okay. Actually, fine. We are using two loops, and this is adding elements in the priority queue, and then making a list out of that is happening in the same loop. Okay. They return. It's not poll. If next is not null, then add that. If tail is not null, what's tail? Min node. Tail dot next is min node. Tail is equal to tail dot next. for each node head. If node head is not null, return add that min heap size next result plate. Okay, yeah, that was it. That was the video. Yeah, I don't have anything to say. Bye bye.